Dear students, in this video we are going to see how to design voltage series feedback amplifier by using multisim tool. So it is a kind of software which help you how to design a circuit and how to measure the output response as well as output waveform. So if you want to design a voltage series feedback amplifier, first of all you should know how to design a circuit with help of the basic components. So here this circuit consists of BC107 NPN transistor and along with resistors, capacitors and even biasing unit, and input we are generated with help of AFO and output we are going to see with help of CRO. So let me start our design from the component selection. So first of all we should select transistor, then one by one we are going to select. So for that, in order to select the basic components required to construct the circuit, we start from transistor. So here in the top of the menu you can find n number of components. Here the fourth one is a transistor, and among that we are going to use NPN type transistor. So and the specification is this is BC107. So we have to type BC107. So it comes, and I am selecting BC107. Yeah, and after selecting a transistor, then we have to select a resistor as well as capacitor. The same way here on this menu you can find the component selection. I can see the left hand side resistor. So how many number of resistors? So totally 4 number of resistors required. So I am selecting one by one. Yeah, 4 resistors are selected, and you can see in the circuit, so R1, R2, R3, R4, 4 resistors are required. Similarly 1, 2, 3 number of capacitors required. That is also we have to select with the same way. So your capacitor, I am selecting 3 capacitors, 1, 2 as well as the third one. So after selecting capacitors, now we are going to select a biasing unit. The same way, so we are going to select the biasing unit. So here I am changing all groups, and sources and diode transistor. So I am selecting sources. So I'm going to power sources. So we are going to connect a DC voltage only, that is a battery. So DC power, and it is selected. Then with help of AFO we are going to generate the input frequency, so that we have to select AFO also. So in order to select AFO, the right hand side you can see n number of menus. So multimeter, function generator, wattmeter and oscilloscope. So here the second one is function generator. I am selecting function generator. Of course we are going to measure the output even CRO. So that is also we are selected here. And all the components I think all are selected, and the one more components we have left out in the design, that's a ground terminal. So that is also we have to select. So here the same way. Yeah, if I am typing whatever the components required, if in the search column, the search bar, you can type directly the name of the components which you required, and that will appear in the right hand side, and you can select. Yeah, the ground terminal also we have selected. So next, one by one we are going to connect the components along with the help of wire. So we start from a transistor. So the transistor base terminal is connected to 10 microfarad capacitor. So here we are having the capacitor value, that is 1 microfarad. So you can change the capacitor value based on our requirements. For that we have to double click this particular capacitor icon, and I can able to change the value, where here capacitance we can vary the capacitor value based on your requirement. So immediately that value also getting changed. So the base terminal of transistor that is connected with capacitor. So the line indication in terms of red color you can see, and the other side of capacitor, the other terminal actually connected to positive terminal of AFO. Yeah, it is also connected. Now the base terminal connection is over, and across base terminal we are having voltage divider resistors, the potential divider resistor R1 and R2, and the respective values 33 as well as 4.7 kilo ohm. So we are having resistor, 2 resistor, so that can be changed the directions in order to have a potential divide purpose, and I can move the resistors. And the R1 resistor value, that is 33 kilo ohm, so you can change the value 33 kilo ohm, and R2, that is 4.7 kilo ohm, 4.7 kilo ohm. So now these two resistors are connected across base terminal, as you can see the circuit. So these two resistors are connected across base terminal. Okay, then R1 resistor having connection with respect to R2, and other terminal of R1 directly towards VCC. So the VCC positive is connected to R1, and the base side the connections are over. Coming to collector terminal, in collector terminal we are having 3.3 kilo ohm, plus 3.3 kilo ohm, and that should be connected to biasing unit. So from the collector terminal one more capacitor is connected, that value is 10 microfarad. The other end of capacitor connected to the CRO unit. So the value of capacitor is 10 microfarad. Yeah, one end is connected to collector terminal. The other end is connected to positive terminal of a CRO. And coming to emitter terminal, so in emitter terminal we have a parallel network, that is resistor and capacitor. RC network is formed, and the corresponding value also we have to be changed. So R4 470, that is R3 470 kilo ohm, 470 ohms, and the capacitor 100 microfarad. Yeah, now we are going to connect the ground terminal also. Now all the other side of the bottom side components are commonly connected. I think all connections are over except the battery terminal. Yeah, once again we have to verify the connection, and VCC 12 volt, then C110 microfarad, 33 kilo ohm, 4.7, 3.3, 470, 10 as well as 100 microfarad. Okay, so before we are going to simulate this particular circuit, so we have to change some simulation parameters. For that, at the top of the menu you can find simulate. So under the fourth one, analyze and simulation. So in analyze, go to AC sweep and you can set the frequency 1 Hz to 10 Hz. Similarly, output, what type of component or terminal is connected to the output section. So here you can see, yeah, this is the component, and you can click this particular component and you can find properties and the net name. The component number is 5, so that should be added. Again, once again, simulate, analyze and simulation, AC sweep, output, component 4. So this component is added, save. Then we have to run this particular circuit. Yeah, here you can see the frequency response of voltage series amplifier, the first one. So the second graph does not require for us, so it should be completely eliminated, and still you can able to see the full frequency response of voltage series amplifier. So if you the objective of measuring the frequency response, we have to find the bandwidth or frequency of this particular voltage series amplifier. So for that we have to find upper cutoff frequency as well as lower cutoff frequency. Yeah, here this frequency response shows exactly linearly increasing and get constant this entire duration, and from this point the response is decreased. So we have to find the exact upper frequency as well as the lower frequency, so that we can find the bandwidth of the particular amplifier. So here you can see 8.99 megahertz upper frequency, and here it is 234 kilohertz. So bandwidth equal to upper cutoff frequency FH minus FL, so that is 8.9, almost 9 megahertz minus 234 kilohertz. So from this you can find the bandwidth of the particular amplifier. Thank you, students. Dear students, once you understand how to design a voltage series amplifier, so from the design concept you can able to design current series feedback amplifier also. So here we have a circuit, the same kind of procedure also we are going to follow here, and we are going to measure the frequency response of current series amplifier. So before we are going to simulate, so once again we have to check the analyze and simulation part. Yeah, AC sweep, that is already fixed, and the output, still the components also, it is already connected because this particular experiments already have done. So here we can straight away see the response of this current series amplifier, and here you can see the response of current series amplifier. Yeah, and you have to measure the cutoff frequency of both upper side as well as the lower side. So the upper cutoff frequency, you can measure the 8.6 megahertz, and lower cutoff frequency, it's around 9.8 hertz. So from this you can find the bandwidth of the current series feedback amplifier. Thank you, students.